The quantum mechanical model of the atom, it's a model that we use to explain how the electrons exist in an atom, and we look at the location of those electrons where we can find electrons with a high probability in an atom. We know that we have these three different types of subatomic particles: protons, electrons, and neutrons. The protons and the neutrons are located in the nucleus of the atom. The electrons are around the nucleus. Okay, so the electrons are moving around the nucleus, but there's a place that it's called an orbital. And an orbital is just a volume in space where we can find those electrons, or there's a high probability of finding the electrons. Now we have a very simple model for the atom. That's the Bohr model, which is the diagram that I have here. It looks like a planetary model. You have something in the center, and then around we have the different energy levels that are going to contain the orbitals. So the center of the model of the atom is the nucleus. In that nucleus, you have the protons and the neutrons. Then around we have orbits. The orbits are the energy level, and in each energy level we're going to have orbitals. So I'm labeling here just three different energy levels, N1, N2, and 3. So N1 represents the first energy level, which is the one that is closer to the nucleus. Then we have N2, and then we have N3, which is going to be the energy level, the level that is the farther away from the nucleus. There's not just three energy levels around a nucleus. We can have from 1 all the way to 7 different energy levels, but we're looking at only the first three. So I have here the Bohr model of the atom again. Okay, so you have your nucleus and then you have different energy levels. So now we're going from something that is very general, right, very broad, that energy level, different energy levels around the nucleus, going to things that are more specific. Those things that are more specific are the sub levels that we have in each energy level. The sub levels are the specific type of orbitals that we have in the different energy levels in an atom. So I have my first energy level right here, which is the one that I have right here in my diagram, the one that is closer to the nucleus. In that first energy level, we have one orbital or one type of orbital. That type of orbital is an s orbital. Whenever we have an s orbital, we have only one of them. So in the first energy level, the one that is closer to the nucleus, we have one s orbital. It's just one. Now we move to the second energy level right here. On the second energy level, we have two sub-levels. Two sub-levels means that we have two different type of orbitals. Those two type of orbitals are an s orbital and a p orbital. Second energy level, two types of orbitals, s and p. For s orbitals, we always have one of them. So we have one s orbital in the first energy level, and now we have an s orbital on the second energy level. For the p orbitals, that specific type of orbital, we always have three of them. Okay? So on the second energy level, we have one s orbital, and then we have three p orbitals. And finally, we are looking at the third energy level. The third energy level has three sub-levels: S, P, D. So you have your third energy level containing three sub-levels. Those three sub-levels are the specific type of orbitals that we have in that third energy level. Whenever you have an s orbital, right, we have one of them. P orbitals is three of them, and now d orbitals it's five of them. So on the first energy level, we have just one s orbital. On the second energy level, we have two different types of orbitals: the s, which we have just one of them, the p orbitals, which we have three of them, and then on the third energy level, we have s, p, and d orbitals. For the s orbital, it's one of them. For the p orbitals, it's three of them. And then for the d orbitals, we have five of them. So we're going to use that information, your different energy levels and the sub levels that we have in each one, to actually accommodate the electrons for the atoms. This is to write down the electron configuration. How many electrons do I have in the first energy level? In which orbital? How many electrons I have in the second energy level? In which orbitals do I have those electrons? Same thing for the third energy level. The more electrons you have in an atom, the more orbitals are required to actually accommodate those electrons. Before we start writing the electron configurations, let's go and check some things in here. I'm writing down the same things that I have on the table. First energy level is an s orbital. So I have here my first energy level. It's represented by that number. That number is my first energy level. In that first energy level, I have an s orbital. Now we move to the second energy level. Second energy level is represented by that number 2. In the second energy level, we have s and p orbitals. And then finally, we move to the third energy level. On the third energy level, we have, and I'm missing something here because on the third energy level, we have p and we also have d orbitals. So third energy level, we have three different types of orbitals. It's the s, the p, and the d. Now, what I have on the right side is exactly the same but represented in a different notation. So you have one s and I have just one line because that's an s orbital, and for s orbitals you have only one line. Let's see. S orbital right there is just one line. S orbital on the second energy level right there, just one line. S orbital on the third energy level, that's just one line. When we're looking at the p orbitals, we always have three of them. So for your p orbitals, we have three lines on the second energy level because we don't have p orbitals on the first energy level. We start having p orbitals on the second energy level. And then on the third energy level, we have 3p. And for your p orbitals, we have three lines because we always have three orbitals that are p orbitals. For the d orbitals on that third energy level, for d orbitals, we always have five of them. So that will be five lines for the d orbitals. Now to write down the electron configuration, we start with the first energy level, which means that for any electron configuration that we're writing down, we're starting on the 1s orbital. first energy level in that s orbital on the first energy level. We cannot put more than 2 electrons per orbital. So let's review. For s orbitals, you have one of them. So whenever you have an s orbital, you can have 1 or 2 electrons in that s orbital, no more than 2. When you're looking at the p orbitals, for p orbitals, we have 3 of them. In each orbital, we can put up to 2 electrons. So when you have p orbitals, the number of electrons can go from 1 all the way to 6 because we can put 2 electrons per orbital. Since we have 3 orbitals, that means that you can have up to 6 electrons. For the d orbitals now, we have 5 d orbitals. In each one, we can put up to 2 electrons. So on any d orbital, we can have up to 2 electrons. Since we have 5 of them, the number of electrons in d orbitals can go from 1 all the way to 10. So I'm going to start writing the electron configuration for. Actually, let me write down something here before we move to the electron configurations. This is up to 2 electrons in the s orbital, up to 2 electrons s orbital. P orbitals up to 6 electrons. So whenever it's an s orbital, it's 1 or 2. Whenever it's a p orbital, it can be from 1 all the way to 6 electrons. So now I'm going to start. So for hydrogen in the periodic table, you can check your periodic table. Hydrogen is element number 1, which means that you have 1 electron. So electron configuration for hydrogen, we're going to start in the first energy level. In the first energy level, we have the s orbital. And now, for hydrogen, we have 1 electron. So we need to put 1 electron in that s orbital. So what you have for hydrogen is an electron configuration that is 1s1. Now we move to the second element in the periodic table, which is helium. Starting at the first energy level, again, that's 1. In the first energy level, we have an s orbital. Now for helium, we have 2 electrons. So we need to actually accommodate 2 electrons in the orbital. In your s orbital, you can have up to 2 electrons. So for helium, we're going to have 1s2. Now, if the s orbital can accommodate up to 2 electrons, when we move to lithium, right? Lithium has 3 electrons, so you cannot write down 1s3 because in that s orbital you can have up to 2 electrons. So for lithium, we're starting again in the 1s, first energy level, the s orbital. Now in that s orbital, the maximum number of electrons that you can have is 2, up to 2 electrons. So you're done with the first energy level, and the sub level, which is an s orbital, it's full up to 2 electrons, so that's done. So now we have to move to the second energy level. On the second energy level, the first orbital that you have is the s, and in that orbital you can have 1 or 2 electrons. The total number of electrons for lithium is 3. You already have 2 electrons right here in the first energy level in that s orbital. So what you're missing to have the complete electron configuration for lithium is just 1 electron. So on that s orbital on the second energy level, you have just 1 electron for lithium, and that gives you a total of 3 electrons. 2 in the s orbital on the first energy level, 1 in the s orbital on the second energy level. So now we move to beryllium, element number 4. So 4 means that you have 4 electrons. So electron configuration starting at 1s, you can have up to 2 electrons, so that one is done. And now we move to the 2s, and in the 2s you can have up to 2 electrons. So that gives you a total of 4 electrons, which is the number of electrons that you have for beryllium. Boron, element number 5, starting again in 1s, you can put up to 2 electrons there. Now we move to the 2s, you can put up to 2 electrons there. So check what's happening with boron. You have 4 electrons right there, 2 in the 1s, 2 other electrons on the 2s. So that's 4, and I need 5. So now we move from the 2s right here to the 2p. So now I go 2p, and what I'm missing is just 1 electron to complete 5, and now I have 5 electrons. 2, 4, and 5. So the 5 electrons for boron are in 2 of them in the first energy level, the s orbital, 2 of them on the second energy level in an s orbital, and the last electron for boron is on the second energy level in a p orbital. So we move to carbon, 1s2, 2s2, 2p2. Now we have 6 electrons. For nitrogen, it's 7 electrons, so we keep adding them. 1s2, 2s2, 2p3, 2, 4, 7. Oxygen with 8, 1s2, 2s2, 2p4. And the last one right here, 1s2, 2s2, 2p5. 5, 7, plus 2 right there, it's 9. So let's do one more, neon with 10 electrons. You see, in the p orbitals, you can have from 1 all the way to 6 electrons, up to 6 electrons, because you have 3 p orbitals and you can have 2 electrons in each one. In the s orbital, you can have just up to 2 electrons because it's just one s orbital. So for neon, we start again at 1, 1s2, 2s2, and now 2p6. 2 electrons, 4 electrons plus 6, that's a total of 10 electrons. Now for neon, you see on the second energy level we have the s and the p orbitals. On the s orbital we can have up to 2 electrons. On the p orbitals we can have up to 6 electrons. So for neon we already use all the orbitals in the first and the second energy level. Now we're going to use a different notation to write down the electron configurations. So I have on the top part here 1s, which is the orbital in the first energy level. You can have up to 2 electrons. Then you have 2s and 2p orbitals on the second energy level. On the s orbital, you can have up to 2 electrons. On the p orbitals, you can have up to 6 electrons. And then we move to the third energy level. You have 3s, 1s orbital up to 2 electrons, 3p, 3p orbitals up to 6 electrons. So we're going to use a short notation to write down the electron configuration. To use the short notation, I have steps here that we can follow. I have the electron configuration for neon up here, which is the last one that we wrote. 1s2, 2s2, 2p6, that adds up to 10 electrons. So we're going to use the short notation to write down the electron configuration for sodium, magnesium, and aluminum. Now, following the steps, right, we need to use the periodic table. So the numbers that I have up here in your periodic table, 1 through 8, that's the main groups. Group number 8 is the noble gases. So the first thing, following my steps, I'm writing down the electron configuration using short notation for Na, which is sodium, element number 11 in the periodic table right here. So first step, finding the element in the periodic table, that's what I just did right there, it's sodium. Second step, go back and find the preceding noble gas or the noble gas with a lower or right before the element that you're trying to get the electron configuration for, right before a lower number of electrons, and you will see why. Go back, going forward, it's sodium forward to noble gas argon, but you have to go back. Going back means that we're looking at neon right before Na. Write the symbol of the noble gas in brackets, so neon. Complete the electron configuration using the periodic table, or we can actually use this right here. You have the electron configuration for neon with 10 electrons, 1s2, 2s2, 2p6. When we write down this right here, neon in brackets, it means that we have 10 electrons right there. 1s2, 2s2, 2p6. You see why it has to be neon and not argon. If it's argon, that's 18 electrons, and for sodium you need only 11 electrons. So it has to be the preceding noble gas, okay? Not the one that is after the element that you're trying to write down the electron configuration, but the one that is before. So I have neon with 10 electrons. For sodium, we need 11 electrons. So now I have to just complete the electron configuration from 10 to 11. Look, 10 electrons, it's this right here, all the way to 2p6, which means that what comes after 2p6 is 3s. Since you have 10 electrons for neon and we're using that one, what it's missing to get to 11 is just 1 electron. So let's do magnesium. First, finding the element in the periodic table. Magnesium is right next to sodium. The noble gas with right before magnesium will be neon. So in brackets, I'm going to write down neon. That's 10 electrons. For magnesium, we need 12 electrons. So 2p6, right after 2p6, what we have is 3s. And then it's 12 electrons, so we're going from 10 right here and 2, that will give you 12 electrons. The last one, aluminum, is right here on your periodic table. Element number 13. Element number 13, the noble gas that is right before that element will be again neon with 10 electrons. So now we have 10 electrons here and we have to go all the way to 13 electrons. If you check up here, that's neon all the way to 2p6. Then right after that it goes 3s2. That's 12 electrons, the same thing that we have for magnesium. But for aluminum we need 13 electrons. So in the s orbital we can put up to 2 electrons, so that's full already. So we have to move now to the 3p. Since it's 13 electrons and I already have right here 12 electrons, that's 10 right here plus those 2 electrons, that's a total of 12. We're missing just one to get to 13, and that will be 3p1. Now I'm going to use the periodic table to add some information to it. That's the main groups 1 through 8, that part you already have. Now I'm going to put numbers right here. So 1 through 7, those are the periods in the periodic table. Okay? So main groups, groups or families, and then we have periods. The groups or families, they are vertical columns. So that's your group 1 right there. Now the periods are across the periodic table. So for example, period 3 in your periodic table starts here in sodium and it goes all the way to argon on the right side. The second period starts with lithium and it goes all the way to the other side on the periodic table where you have neon. You have this space here in your periodic table, but if you check your atomic numbers, magnesium is 12, and then on the other side of the periodic table, what you have is aluminum with an atomic number of 13. Okay, so they go all the way to the other side. Now I have some of the electron configurations that we just wrote down. I copied them here so we can go over some things. Looking at hydrogen and lithium. For hydrogen, I have 1s1. For lithium, I have 1s2, 2s1. So you see, the last thing that I wrote for lithium starts with a 2. Beryllium, the last thing that I wrote with for beryllium starts with 2, 2s2. The last thing that I wrote for lithium and for hydrogen. Look, hydrogen is S1, lithium is S1. Hydrogen and lithium are both in the same group in the periodic table. which is group number 1. So for both of them, the last thing that I wrote in that periodic table is S1. If you check the electron configuration for sodium, you have 1s2, 2s2, 2p6, 3s1, also S1. We didn't write down the electron configuration for potassium or rubidium, but we can assume based on what we have so far that everything in group 1 is going to have an electron configuration that ends in S1. Actually, let me change that color because that's the same one that I have for the period number, very similar. So let's use something different. Let's use this blue here. Now, when you look at the electron configuration for beryllium, beryllium ends in S2, and beryllium is in group 2. Group 2 S2. If we write down the electron configuration for magnesium, and I'm going to write down the short notation here. It ends in S2 also. We didn't write down anything for calcium, strontium, or any other element in that group number 2. But based on what we have for these two, we can predict that everything in group 2 is going to have an electron configuration that ends in S2. So let's check the other side of the periodic table. We start with boron, and boron ends in P1. We did the electron configuration for aluminum, neon, 3s2, 3p1, 13 electrons, 10, 12, and 1, 13 electrons. The last part in your electron configuration for aluminum is P1. So boron and aluminum are in the same group in the periodic table. They end in P1. So for carbon we have P2, and for F we have P5. So I'm going to go ahead and write down here carbon group 4, it's P2, and F group 7, it's P5. So we can actually look, I'm not giving you anything for nitrogen or oxygen or anything on the last group in the periodic table. But if boron starts in P1 and carbon is P2 and it goes all the way to P5 where you have F, we can predict that for group 5 we're going to have P3, for group 6 we're going to have P4, and then we have P5 for group 7, which means that group 8 will be P6 starting with neon. Helium, you don't have any electrons in p orbitals because it's just 2 electrons, and the electron configuration for helium is 1s2. There are no electrons in p orbitals for helium because we don't have enough electrons to get all the way to the p orbitals. But starting with neon, you will have the last thing that you have in that electron configuration will be P6. So you have here Si and Cl, and you can write down the electron configuration for those two using the short notation and the periodic table. You can also use this one here to help you. Now another thing is the number. You see how I was underlining this number here. For hydrogen, you have 1s1. For lithium, the last thing that you have is S1, same as hydrogen, but now that's a 2. For beryllium, again, the last thing that you have is S2, which is shared with magnesium, both of them S2. But for beryllium, that last orbital is in the second energy level, that's the 2. For magnesium, that last orbital is on the third energy level. We move to boron and aluminum. Boron, the last thing that you have, your P1 has a 2, the second energy level. For aluminum, the last thing that you have in the electron configuration is P1 with a 3 on the third energy level. That green number that I'm underlining is the period number that you have on the periodic table. Hydrogen 1s1, 1, because hydrogen is in period 1 in the periodic table. For lithium and beryllium, the number that you have with S1 and S2, for lithium it's 2 because lithium is on the second period in the periodic table. Beryllium 2s2 because beryllium is on the second period in the periodic table. Aluminum, the last thing that you're writing for aluminum is P1, but it's 3P1. 3P1 because aluminum is on the third period on the periodic table. Period 1, hydrogen and helium. Period 2, from lithium all the way to neon. Period 3, from sodium all the way to argon. So now let's do some other examples about writing the electron configuration using short notation, but with the help of the periodic table. So again, the first step is to find the element on the periodic table, and we're looking at phosphorus, which is element number 15, and it's right here. So next we have to find the noble gas that you have right before element 15, and that noble gas will be neon. So writing that in brackets means that we already have an electron configuration for 10 electrons right there. Atomic number for neon is 10. So when we write down neon right here, we already have 10 electrons. So now we need to complete the electron configuration. Atomic number for phosphorus is 15. Since we already have 10 electrons right there, we need to add electrons all the way to 15. So let's look at the periodic table to do that. Phosphorus is in period 3 on the periodic table, right here, period 3. On the right side of the periodic table. To get all the way to 15 from 10, neon 10, to get all the way to 15, look at what we're passing through. 3 S2, 3 P3. Phosphorus is in group 5. The last thing that we write down on the electron configuration for group 5 is P3. So I'm going to write down that right here, P3, from the periodic table. That P orbital is on the third energy level because phosphorus is in period 3. Now 10 and 3, that's just 13 electrons. So the other 2 electrons are the 3s. So you see 3 right here, S2, 3, all the way to P3. And we have 10 electrons here, plus 2, 12, plus 3, 15 electrons. Whenever you're writing the electron configuration, it's very important that you actually check that the number of electrons that you're writing in your electron configuration is the same as the total number of electrons that you have. So let's do S using the short notation. S is right next to P on the periodic table. It's element number 16. So noble gas that we're using again is neon, 10 electrons. Then after that we go to 3s2, and after that S, it's in group 6, and what we have for group 6, it's P4. Since S it's in the third period, those 3p4, those p4, that p orbital is on the third energy level. The last one for calcium. Calcium is all the way on the left side of the periodic table, right here. Element number 20, we need 20 electrons. 20 electrons, the noble gas that you have right before calcium, it's argon. For argon, we already have 18 electrons. So you see, you have 18 electrons and you need 20 electrons. So let's check where calcium is on the periodic table. Calcium is in group 2, period 4. For group 2, what you have is S2. So I'm going to write down that. Group 2, look, I'm reading at this part right here. Group 2, S2. Calcium, it's in period 4 right here. So the number that you need in front of the S2 is 4. You have 18 electrons right here, plus 2 electrons right here. That will give you a total of 20 electrons.